Hi. In the previous video, we have seen how to implement any Boolean function using multiplexers. So we'll continue the same thing. In the last video, we have seen how to implement three variable Boolean function. In this video, we'll see how we can implement a four variable Boolean function. Okay. So have the number of variables as n is equal to 4, or I can say small n is equal to 4, which means I'll be having 2 power 4, that is 16 possible combinations, right? And I can implement this using 16 is to 1 mux, 8 is to 1 mux, or even 4 is to 1 mux. Okay. In the exam, they'll ask you to implement this four variable Boolean function either by using 8 is to 1 or by using 4 is to 1. These are the two mainly asked questions. Okay. Two mainly asked implementation. So first we'll try to implement this using 8 is to 1 multiplexer. In this 8 is to 1 multiplexer, you'll be having 8 inputs, 1 output, and this 8 is nothing but 2 power 3. So we'll be having 3 select lines. 8 inputs, 1 output, and 3 select line. Okay. Now, but what happens, as I've told you in the previous case, out of the input variables, the variables that is given in the question, you have to select which one you want to connect to the select line of the multiplexer. And whatever is remaining will go to the input side. Okay. If you are going to implement this using 16 is to 1 multiplexer, you don't have to, you'll not be having any left out variable there, because 16 is to 1 will be having 4 select lines, correct? So all 4 input variables will be given to the 4 select lines. And on the input 16 inputs that you have on the multiplexer, the numbers which are given in the question, for those numbers you have to connect VCC or 1, and the remaining numbers will be equal to 0 or ground connection. Okay, roughly I'll just show you how it is done. You have 16 inputs here, 0, 1, 2 up to 15. Okay, and this is one output. 4 select lines are there. So A, B, C, and D. All 4 variables will be connected to the select lines. Whereas here on the input side, whichever number is specified, no, you short them 0, 2, then 3, and so on, and connect it to 1. The numbers that are given in the question should be given to 1 or VCC. Connected to VCC, which indicates logic 1. And the remaining numbers will be shorted and connected to 0 or ground. Okay, so numbers specified in the question should be connected to logic 1, and the remaining numbers should be connected to ground. This is direct without any table required. You can draw the implementation circuit if you are using 16 is to 1 for 4 variable. Okay, but in the questions, most of the time they will be asking you to implement it using either 8 is to 1 or 4 is to 1. In that case, how do we do it? So we'll require implementation table for that, and we'll see how to write the implementation table for the first case, that is 8 is to 1 mux. So as I told you, for 8 is to 1 mux, we have only 3 select lines, which means out of the 4 variables, I'll have to select only 3 of them and connect to select lines. And the fourth variable which will be left out should go to the input side, right? Now, let's try to implement this assuming A, B, C are given to select line, and the left out variable D should go to the input side. Okay, so this is my condition now. In the question, they're saying implement the given function using 8 is to 1 multiplexer, assuming ABC or taking ABC on the select lines and D on the input side. Okay, so first we'll try to draw the implementation table for this. So if you have 4 variable, you know that 16 possible combinations are there, which means totally you should have 16 cell. Okay, 16 boxes should be there. And I also mentioned how to count on the number of rows and number of columns. If you have only one input indicates how many rows you want, and select lines indicates how many columns you want. Correct? So here, since I have only one input, that is D, it can be either 0 or 1. So which means two possible values are there, two rows. If I have three variables, I will be having 8 possible combinations. So number of columns will be 8. So I'll have to draw it. I have 2 rows and 8 columns. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so two rows for the input D, which can be either 0 or 1. Based on that, this becomes D bar and D. And here you have select lines for A, B, C value. So this will be 0, 0, 0, 0, 0, 1. 8 combinations. Okay, 0, 1, 0. There is 2, 3, 4, 5, 6, and 7. So three variables are there. So 8 possible binary combinations you have written here. The next step will be to write down the numbers inside these boxes. And I hope you remember how to write it. Read the binary uh, digits in the order in which it is given in the question. Okay. So it is A, B, C, D. So 0, 0, 0, 0 will be 0. 0, 0, 1, 0. That is 2. 0, 1, 0, 0 is 4. 0, 1, 1, 0, 6. Next is 1, 0, 0, 0. That is 8. 1, 0, 1, 0, 10. 1, 1, 0, 0, 12. 1, 1, 1, 0, 14. Okay. Next 0, 0, 0, 1. 0, 0, 1, 1, 3. 0, 1, 0, 1, 5. So you have 0, 2, 4, 6, 1, 3, 5. The next one is automatically going to be 7. Okay. That is 0, 1, 1, 1. Next you have 1, 0, 0, 1, 9. 1, 0, 1, 1, 1, 11, 10, 11, 12, 13, 14, 15. Please don't take it as a default that it's going to be like this. Please read the numbers in the proper order and then write down these cell numbers. Okay. This will be 1011 is 11, 1101 is 13. All four ones will be 15. Main thing you have to remember is read the numbers in the order in which the variables are mentioned in the question. Okay. Since I have A, B, C here, I'm going to start from here. A value, B value, C value, and then D value. Okay. So once this table is ready, the next step would be to circle the numbers specified in the question. So 0, 2, 3, 6, 7, 9, 11, 13, and 14. Okay. And as I've mentioned, each column of the table, implementation table, tells you one of the input to the multiplexer. Okay. It gives you the input of the multiplexer. Since we're using 8:1 mux, I have 8 inputs, I0 to I7. I need to find out what are these values now. Okay. And I told you if both are selected, answer is 1. If none of them are selected, answer is 0. And if one of them is selected, the corresponding variable should be written here. Okay. So in the first case for I0, it is going to be D bar. For I1, since both are circled, it is 1. I2 will be, none of them are selected, so 0. And I3 is, both are selected, 1. I4 will be equal to D. I5 is also D. I6 is D. I7 is D bar. So you have all the 8 inputs ready. You just have to now draw the final circuit. Okay. So you have 8 inputs and 3 select lines, 1 output for 8:1 marks. So this is I0, I1, 2, 3, 4, 5, 6, and 7. And here you have 3 select lines, S0, S1, S2. And according to the question that we have taken, we are supposed to connect A, B, and C to the select line. Now for the input side, what is I0 value? It is equal to D bar. I7 is also D bar, right? So let's say this is your D. If I want D bar, I have to use a NOT gate. And this I0 and I7 both are shorted and connected to D bar. Okay. Next is we want I1, I3, which are equal to 1. So you can short these two, I1 and I3, and connect it to logic 1 or VCC. Okay, you can show it as logic 1 or you can just show it, connect it to VCC. That will also do. Next, I2 is 0. So you can connect I2 to either 0 or you can make it equal to ground. Okay. Then remaining I4, I5 and I6. All three are equal to same thing, that is equal to D. So I can take this D from here and connect it to all three of them. Short and connect it. So this is the circuit. You have implemented the given Boolean function using 8:1 mux. So I hope this is clear. In this case, you took ABC as select lines. Next, you can try with some other combination. You can take A, C, D select line, or you can take B, C, D as select line, right? Or you can take A, B, and D as select line, and then you can implement this table. Okay, so we'll solve one more question. Let's see. We'll take ACD as select line and try to solve it. Remaining two combinations, you can give it a try. Okay, right. So I'll just take a random function here first. So 1, 3, 5, 7, 8, 10, 12, 14, and 15. Some random function I've taken. And the question is, I want to use ACD as select line. Okay. So again, first try to draw the implementation table. Since you're going to use 8:1 multiplexer, the table is going to be the same, 2 rows and 8 columns. Okay. When you're trying to implement a 4 variable, when you're trying to write implementation table for 4 variable using 8:1 mux, it will have default 2 rows and 8 columns. But the numbers inside the cell will change based upon what input variables you're using as select lines. Okay. So this decides the numbers inside the table. 7 and 8. Okay. So here, since I'm using A, C, and D on the input side, out of A, B, C, D, A, C, D is used for input. So left out variable will be B, which is used for the input side. Okay. A, C, D are used as select lines. So the variable which is not here is B, that comes on the row, that is input side. Right. Next, we'll write the numbers inside the table. Now read it in the proper order: A, B, C, D. So 0, 0, 0, 0, 0, 0, 0, 1. A, B, C, D. Okay. 0, 0, 1, 1. 1, 0, 0, 0. That is 8. 1, 0, 0, 1. 1, 0, 0, 1. That is 9. Okay. 1, 0, 1, 0. Then 1, 0, 1, 1. Right? So first A value, then B value, C, D. So 0, 1, 0, 0, 4, 5, 0, 1, 1, 0, 6, 0, 1, 1, 1, 7. Then 1, 1, 0, 0, 12. Next one is 13, 14, 15. Right? So if you know how to write these numbers, no, half of your problem is done. Writing these numbers is what is important in this, because rest of the things you will be able to do it, because it's just circle the given numbers in the question and then you have to write down each input. Okay, but writing these numbers will be the main step. If you make any mistake in writing the cell numbers, then your entire problem will become wrong. Okay, be very careful when you're writing it. Remember, always read the digits in the order in which it is mentioned in the question. It need not be A, B, C, D. They can give you W, X, Y, and Z also. Or it can be P, Q, R, S. Just look at the order in which it is mentioned, and in the same order, read the digits here and write down the corresponding decimal number. Okay. So now let's circle them. 1, 3, 5, 7, 8, 10, 12, 14, and 15. So 1, 3, 5, 7, 8, 10, 12, 14, and 15. So now I can write the inputs. The first column gives me I0, which is 0. I1 is 1. I2 is 0. I3 is 1. I4 is also 1, I5 is 0, I6 is 1, I7 is D. Only one of them is selected and corresponding value is D. Okay, so I hope you know how to write this. So once your inputs are ready, you can finally draw the circuit. 8 is to 1 marks circuit. So it's your F. 3 is select lines. When you're writing this, please be very careful. This time the select line is supposed to be A, C, D. A, C, D, not A, B, C. Okay, A, C, D. So here you have I0, I1, I2, I3, I4, I5, 6, I7. Okay. Whichever has common value, you can short it. I0, I2, I5. I0, I2, I5. All are connected to ground. It is zero, logic 0. I1, I3, I4, and I6. We have I1, I3, I4, and I6. All of them are connected to either VCC or you can say logic 1. Okay. Whereas the last I7 is connected directly to input D. So this is a circuit diagram for the given question. Similarly, you can try with different variables. Say suppose you have, I'll give you a question. You can just work it out. F of W, X, Y, Z. Summation M 0, 1, 5, 8, 11, 13, 15. Okay. And I want you to use W, X, and Z as select line. Right? So you can give it a try. You can randomly take some inputs and you can try it on your own and solve as many problems as possible. So this is how you can solve or implement any given Boolean function, 4-variable Boolean function using 8 is to 1 max. Right? So next we'll move on to the second half of this, the last part of this implementation of Boolean function using multiplexers. Same 4-variable, but right now I want to implement it using 4 is to 1 mux. Okay, the second case is using 4 is to 1. When I have a 4 is to 1 mux, I have 4 inputs, 1 output. 4 is nothing but 2 power 2, which means I'll have 2 select lines. So out of the 4 variables, only 2 variables will be connected to select lines and remaining 2 variables will have to be put on the input side. Okay, so we'll first try to write down the implementation table for this. So I'll take an example, 4-variable example. So as I told you, row tells me the input. I have, and let's say I want A and C on the select line. Only 2 select lines are there. So I'll take A and C on the select line. Which variable is left out now? B and D. They will go to the input side. If I have 2 select lines, how many columns will be there? If you have 2 variable, 4 possible combinations are there. 0, 0, 0, 1, 1, 0, 1, 1, which means number of columns will be 4. Similarly, on the input, you have 2 variables. So they can take 4 possible values, right? So number of rows will also be 4. So if I draw the table according to that, I'll have 4 rows and 4 columns. 2, 3, 4, 1, 2, 3, 4. On the input side, I have 0, 0, 0, 1, 1, 0, 1, 1 combinations. What are the possible combinations? Draw it. Please don't confuse this with K-map. This is not K-map. And don't follow the K-map numbering system here. Okay, it is completely different from K-map. We call this as implementation table. This comes into picture when you're trying to implement any circuit, any equation using multiplexer. Okay, so don't follow the gray code here. Just write them in the proper order, binary numbering. And here you're using A and C for select line. And here you have B and D as input. If it is 0, 0, this becomes B bar, D bar. This is B bar, D, P, D bar, and B, D. Okay. So now let's try to write the number. The condition remains same. Always read it in the proper order as it is given in the question. A, B, C, D. A, B, A, B, C, D. That is how we have to read now. 0, 0, 0, 0. 0, 0, 1, 0. 2. 1, 0, 0, 0. 8. 1, 0, 1, 0. 10. Okay. Next you have 0, 0, 0, 1. 0, 0, 1, 1. That is 3. 1, 0, 0, 1. 9. 1, 0, 1, 1. 11. Next 0, 1, 0, 0, 4. 0, 1, 1, 0, 6. 1, 1, 0, 0, 12. 1, 1, 1, 0, 14. 0, 1, 0, 1, 5. 0, 1, 1, 1, 7. 1, 1, 0, 1, 13. 1, 1, 1, 1. The order in which I read them is A, B, C, D. Okay. A value, then B value, C, and then D. In that order, you have to read the binary numbers and write the corresponding decimal value inside the cell. So once this table is written, the next step is exactly same as what you have done previously. Circle the values given in the question. 3, 5, 6, 9, 11, 13, and 15. Okay. And now you have to write down the outputs. Each column gives you the I values for the multiplexer. Okay. So if you remember, 4:1 multiplexer is, it will have 4 inputs, 2 select lines, and 1 output. I0, I1, I2, I3, 2 select lines, S1 and S. In your question, you have used A and C for select line. So AC will come here. I need to now find out what I should connect here that I can get the inputs. I know that they are going to be in terms of B and D because those are the two variables left out and connected to input side. But what will be the equation? That is what I have to find out. Again, the rule remains same. If all of them are selected, answer is 1. If none of them are circled in the column, answer is 0. If there are selective cells which are circled, then you have to write the corresponding output of them. Here you see you have more than one which is circled, but not all of them are done. Write down all the corresponding values and add it. I have 1, 2, and 3 terms. Okay, so I have to write D bar plus D bar D plus PD. All the 3 terms I have to add. If all 4 were there, then the answer would have been 1. Okay, but I have 3 of them. I'll add it. Now, if possible, you can try to simplify this equation. I'll take B bar common from the first to 2, then I will get D bar plus D. I'll write VD as it is. I took B bar common, okay? So I'll get D bar plus D. D bar plus D is nothing but 1. So I'm going to get the answer as B bar plus VD. This can further be reduced as B bar plus B into B bar plus D. Distributive law. A plus BC can be written as A plus B into A plus C. You should know the distributive law. Okay, I have used the same thing. So B bar plus B is 1. So finally, I'm getting the answer as B bar plus D for I naught. Okay. So I'll just write it here. I'm getting I naught is equal to B bar plus D. I got the first input which I'm supposed to connect for the 4:1 marks. Now next we'll go for second input I1. For I1, I have only two variables, two cell which is circled here. The first cell is B bar D, second one is BD bar. Both I'm going to take and add. So B bar D plus BD bar. This is nothing but XOR operation between B and D. So I can replace it with this XOR symbol. A bar B plus AB bar is A XOR B, right? So this is B XOR D. I got I2 also. Next, I am so sorry. This is I1. Okay, I naught I1. Next, I'm going to find out for I2. Again, it is B bar D with BD. B bar D plus BD. Can I take D common from these two? Then I'll be left with B bar plus B, where there is nothing but equal to 1. So I'm getting I2 as D. The last one is I3. I3 is also the same thing as your I2, that is B bar D plus BD. Or I can say I3 is equal to, if I take D common, B bar plus B, I3 is equal to D. Okay, so you got all the equations now. You can draw the circuit diagram for this. What is the first one? You have B bar plus D, which means I need a NOT gate to get complement of B, and I need a OR gate so that I can add these two. So I have two gates requirement here. First one is NOT gate. So B becomes B bar from this. And then this output will be connected to OR gate, whose another input is D, from where I'll get B bar plus D. And this is connected to I naught. Okay, so what is I naught? It is OR operation of, let me write it neatly. This is OR operation of B bar and D. And where did we get B bar from? From the NOT gate of B. Okay, NOT of B gives you B bar. So I naught circuit is done. Next, I want I1, which is XOR operation of B and D, which means I need a XOR gate for this. So I'll take XOR gate. One input is D, another input is B. So B XOR D, and that is given to I1. Okay. The third thing is I2 and I3 both are equal to D, so I'll short them and I will connect both of them to, okay, this is how you draw the circuit for 4:1 marks. So I'll just repeat. When you have 4:1 mux and you're supposed to implement a 4 variable function, then remember your implementation table will have 4 rows and 4 columns default. How you're going to write the numbers inside the table depends upon which variable you're using as select line and what will be left out for input side. So based on that, write the numbers and circle the given numbers in the question. After circling, you will be getting each column is going to give you one of the input for the multiplexer. How do you write the equation for how do you write the equation for each column? If all the cell of that column are covered, output is 1. If none of the cells of that column are covered, the value will be 0. If you have selective cells covered, then add all their individual equations. For example, in the first case, I had 3 cells covered and their individual values are B bar D bar plus B bar D plus BD. And once you have written this, if there is scope for simplification of that expression, please do it. Don't leave it as it is because your circuit will become very complex. You would require too many gates in the final diagram, which is not going to be accepted in the Excel. Okay, so please see if it is possible to simplify the equation once you get this. If yes, please simplify so that you can reduce the number of gates in the circuit. Okay. Similarly, do the same procedure, follow the same procedure for the remaining columns. Whichever cells are circled, add the corresponding equations. Simplify if possible. Convert them into proper standard gates, and then you can draw them in this manner to get the final circuit. Okay, so this is how you can implement any Boolean function. It can be 3 variable or 4 variable using multiplexers. Most commonly asked will be 4 variable implementation using 8:1 or 4:1 multiplexer. Okay, so I can give you a question. Randomly, you can choose W, X, Y, Z, some random data. Okay, and I want you to use X and Y as select line. The remaining variable WZ will go to the input side. So you can give it a try and try solving it. And if you have any doubts, you can write it on the comment section. I can get back to you with an answer. Thank you.